You're watching part number 10 of our mini-series about industrial IoT. So far, we've looked at how Parnell Aerospace can take advantage of the Microsoft industrial IoT platform to address their key challenges and achieve their business goals. In this episode, we'll look at how they can go to scale in production. From proof of concept to reality, there is a lot to be considered. The first thing is how to scale asset connectivity and management. Going back to the beginning, what has been shown so far is possible only if we provide a secure and reliable infrastructure for factories and workers. It all starts with connecting those assets. Industrial manufacturing equipment has extended life cycles that can go decades, and replacing older, non-connected machines is just a non-starter. One of the main challenges for manufacturers who want to digitally transform is to securely connect their existing assets and seamlessly integrate them into modern infrastructures. Microsoft and its partners offer solutions that simplify this integration of devices at scale, with large number of devices across many locations while ensuring data security and privacy. We'll see how architects and developers can take advantage of a set of services and features in these services to do exactly that. And who's going to benefit from this asset connectivity and management? Pretty much everyone. So looking at the architecture that Parnell Aerospace put together, we will focus on the Azure IoT part and its device and assets connectivity story. Let me jump into Azure IoT Central to illustrate that. This time, I'm on the landing page of Azure IoT Central that was recently extended to offer a specific first-time experience for industrial IoT scenarios. Directly in the tool, you can learn about the many reasons why Azure IoT Central is the perfect starting point. On this architecture diagram, you can see that IoT Central offers a management web experience for collecting data from on-site equipment, model, transform, and organize the data, as well as integrate data into business applications. One important aspect of Azure IoT Central is that it's built on top of managed PaaS services. The same services you can aggregate on your own if you need more granular control over your application's architectures and configuration. You can leverage Azure IoT Hub, DPS, and the various other services under the hoods like Stream Analytics, Data Explorer, and others we already demonstrated earlier today. Industrial assets can be connected directly to Azure IoT using our open source SDKs or connect through gateways, which in most cases is the scenario preferred in industrial IoT. When they can be connected directly to the internet, whether for security reason or because they don't even support connecting to TCP/IP networks or use industrial field buses or protocols, you can leverage the gateways from our partners or build your own one with Azure IoT Edge. We partner with companies specialized in OT to cloud connectivity to offer plug-and-play solutions, allowing to easily retrofit existing assets as well as unify data coming from various types of equipments. Here you can see a solution from our partner CloudRail, another one from Omni. I would definitely invite you to go and check them out. But here we'll look at how you can connect some PLCs and other industrial assets to IoT Central, leveraging one of these solutions, Omni Edge. Omni Edge comes in the form of a gateway that you connect to your network on one side and to which you attach your equipment. I'm here on the Omni Edge configuration portal, and I have already set up a Azure IoT Central connection, so connecting to my application. And I already imported a device, a Schneider Electric Altivar device, and it's been already set up, and it's connecting over a Modbus TCP protocol to my gateway. I'm going to add a new device. I will pick from a list that Omni Edge put together for me. I'm picking IME as a manufacturer, and the type of device is the 4LE. I will select this firmware, and I will add a label. I will pick the protocol, Modbus again for this one. But you see here, everything was pre-populated for me because Omni did it for me. They read all the manuals and adapted everything for me. I can then pick the telemetry I want. So here I'm going to pick everything. I want all of that data to come up at a specific frequency that I determine into Azure IoT Central. What Omni Edge Gateway will do, it will retrieve the data from the various devices I've set up here in the portal, and will make sense of the data, rationalizing or putting everything in terms of modification into the format I'm interested in. If I have several devices doing the same thing but sending data in different formats, then Omni Gateway will reconcile this data in terms of format, so I will see the same thing on the Azure IoT Central side of things. When I hit save and deploy, the Omni Edge Gateway or portal will leverage the IoT Central APIs in order to import templates for these specific devices I picked, and will allow me to then work in IoT Central with these devices and their data. So switching now to IoT Central, I can see the new templates that have been automatically imported into my application. And I can look at the details here. So that the templates describe the capabilities of the device in terms of the data sets, based on what has been selected in the Omni Edge configuration portal. But what more important than just the templates, what I can do is start building dashboards where I can already see real-time data showing up just after inserting that new device or adding that new device into my application. I can see real-time data. Now I can start building dashboards that my operators will leverage. I can also set up rules, set up jobs to manage these devices remotely, send new configuration, and so on. So you see, it was pretty straightforward to integrate these complex and different types of devices into the world of Azure IoT thanks to Omni Edge solution.